and welcome to A-Level Maths at Hayes School. I'm Mrs Kent, I'm head of Key Stage 5 for Maths. Welcome to M Block, welcome to your induction video. Now you will hear at various points through this video myself and my colleagues saying the phrase, pause the video and have a go at these questions. So it would be great if you could have a pen and a piece of paper in front of you, because you are absolutely not going to be sat there doing nothing and you'll be doing lots of maths. So welcome to A-Level Maths. This is going to be hard work. We are absolutely not kidding. It is one of the hardest A-levels, arguably the hardest A-levels. And even for the best mathematician, A-Level Maths is still hard work. However, it is totally worth it. It's a fantastic qualification in terms of universities and employers. I can genuinely say there is nothing in my life that I have applied for that it hasn't impressed someone that I have A-Level Maths. And more importantly than that, it can actually be really rewarding. I loved doing my A-levels and I hope that you're going to have as good a time as I did. It really is difficult, but it's super challenging and super rewarding because it's difficult. So hopefully the fact that I'm stood here saying to you that it's going to be challenging isn't putting you off, it's making you think, game on, can't wait. So there is a minimum requirement of a grade 7 to enter this course, but please don't be fooled to think that having a 7 at GCSE Maths is anywhere near enough to guarantee success in your course. We've actually had students who've come in on an 8 and a 9 not go on to be as successful as they wanted. So that's more just a guideline, it's certainly no guarantees of future success. The way the course works is you sit 3 papers at the end of year 13. Each paper is 2 hours long and they'll just make up a third of the grade. 2 of those papers are pure papers and then 1 is an applied course, so that is mechanics, which has good links with physics. So those of you also doing physics A-levels will find that particularly fits nicely with your other subjects, and also statistics, which again links quite nicely to things like psychology and biology. You will be allowed to use a calculator in all 3 papers, so those of you who hate mental maths, a little sigh of relief there. Paper 1 and paper 2, the pure papers, have a series of different branches of mathematics that link really nicely into a variety of university degrees, not necessarily just pure maths topics. And all of these topics could come up on any of the pure papers. Being confident on your algebra is absolutely essential. Talk later about the induction work and how important it is to make sure that you spend time over the summer keeping your algebra skills up. Algebra is like fitness in sport. If you don't use it, you will absolutely lose it. So hopefully the following question should be no problem to you whatsoever. Pause the video and have a go at it. Hopefully you've got the right answer there. If not, have a little look to see where you went wrong. Okay, now my colleague Miss Chandler is going to take you through another example of a pure question that you should be able to answer at this time, but links nicely to A-level.
Hi, I'm Miss Chandler and I teach Year 12 Maths. Here we've got another question from the pure papers. I want to see if you can use this equilateral triangle to find the exact value of cos 30, sin 30 and tan 30. What else can you find? Pause me and have a go. Here's our triangle. We know that the top angle will be 60 because it's equilateral, but if we cut it in half, it's 30. We can also cut the base in half, which gives us 1 centimetre. Using Pythagoras, we can find that the vertical height is root 3. Now we can use our sin, cos and tan ratios, once we've labelled it up, to find our values for sin 30, tan 30 and cos 30.
Okay, thank you Miss Chandler. So another thing that's worth emphasising is lots of people take maths because they don't like writing essays and it's one of the A-levels that has the least amount of essays. That is true, but there is still quite a lot of mathematical reasoning that you are required. So one of the big changes that came in at A-level when they changed the specification is they have a lot more of these explain why questions, a bit like those you would see in science. So here's a classic example of one, two different students, and you have to think about the error that's been made by one of the students, and you have to explain what's happened and why this has gone wrong. Similarly, you'll also have to be expected to reproduce proofs from first principles. So those of you who've done further maths GCSEs or have looked at any calculus might know that when we differentiate 3x squared, we get 6x. If not, something to look forward to. However, you might never have been able to asked to prove it from first principles, and you will see that these questions carry quite a few marks, and they are long, quite wordy, quite specific, rigorous proofs. So that's just something worth mentioning because it's a little bit different to what people often expect from Maths A-level. Okay, so the applied section, like I said before, it's divided between mechanics, which fits quite nicely with physics A-level, and there's a lot of overlaps here. Kinematics, in particular, and Newton's laws cross over a lot between maths and physics. And then there'll be statistics is the other half of that paper. These two are split up 50-50, where you'll go on to do things like different statistical sampling, more complex probability, you'll meet the binomial distribution, and you'll look at something called hypothesis testing. I'm going to hand over now to my colleagues Mr. Wassell and Mr. Brown, who are just going to give you a little example for you to pause the video and have a go at a mechanics and statistics question. Enjoy!
Okay, my name is Mr. Wassell. I'm a maths teacher at Hayes, and I teach a lot of Key Stage 5, so I'll almost certainly meet you when you come to the school. A really huge passion of mine is statistics. Further down the school you might have got a bit bored with doing mean, mode and median so many times, but if you do statistics and you get good at statistics at A-level, it's the one thing that if you want to get a job in a bank or in a think tank or in the civil service, it really lends itself to that, and it will make you a lot of money if you want it. So here is a question that is an A-level question, but it involves GCSE maths. Pause the video and have a go. Okay, so the key thing with this is getting the shape of the diagram right. And the shape of the diagram, we're going to have three circles indicating A, B and C. But the key fact is that A and C are mutually exclusive, so they're not going to overlap. And so here is the diagram. Once you understand that A and C don't overlap, then you can really easily plug the other values. And this notation means what is the probability that the event that you picked doesn't sit in the union of B and C. Now the union of B and C is this. And so it's everything outside of that.
Hello Year 11, my name is Mr. Brown and I'm the head of maths in Hayes School, and welcome to your next stage of the induction pack. I'm going to talk to you about one of these problems here, which is all about mechanics. Mechanics is an aspect of the course that you will do along with the pure and the statistics, and some of it will be familiar to you. It's very physicsy based. Here we have a problem talking about a car moving along the road. You've got various bits of information. You've got to work out the acceleration of the car, and you've got to work out the speed of it as it passes through A. Now, as it says here, diagrams are very important when it comes to these questions. Before we do that though, we're going to talk briefly about SUVAT. Now SUVAT is something that you may be familiar with, partly from your maths GCSE, partly from science as well. And SUVAT talks about various equations we use in mathematics. We have an S, we have a U, we have a V, we have an A, and we have a T. Now S stands for displacement, which is similar to distance, but it's how far you move from your starting point. U would be your initial velocity. V is your final velocity. And then two obvious ones. A is the acceleration and T is the time. Now, all of those fit in with various equations. And again, like I say, you may be familiar with some of these equations. We have v is equal to u plus at, so the final velocity is the initial velocity plus the acceleration times the time, and other formulae there as well. We're going to be using one of these formulae when it comes to these questions. So going back to the question, what I've done is I've put the information into a diagram for us. We have an A and we have a B, that's 22 metres, and it takes 2 seconds. And then we have B to C, which is 4 seconds and 104 metres. What I'm going to do is look at the journey in 2 stages, and it's going to generate some simultaneous equations. I'm going to look from A to B first of all, and then to keep my initial the same, I'm going to look at from A to C, rather than looking at from B to C. So what we've got is, looking at A, from A to B, S, our displacement, we've moved 22 metres. U is something we're going to want to find at some point, but we don't know it yet, so I'll just leave that as a U. V, again, is something we don't know, but it may not be relevant to the question, so I'm just going to put a question mark there. A is something that we're again trying to find out, so I'll call that A. And finally, T is something that we do know, and we know that's 2 seconds. Okay, so that's 2 seconds there. If I look at the journey from A to C, I've got a displacement of 22 plus 104, which is 126 metres. Again, we don't know U, but we do know if we're starting from A, it's the same as this U here. We don't know V. We don't know what A is, but it is a constant acceleration. So I can fill in A as just the letter A. And we do know the time. We know that it takes in total 6 seconds to do that. So looking at this, we're going to ignore our V. Each one of those equations involves 4 things, and these are my 4 things. So I've got an S, a U, an A, and a T. And if I look at my equations, this is the equation that I want to use. Okay, the S is equal to UT plus a half AT squared. That involves all the elements I need. So, looking at the question, filling in the actual information, filling in my S as being 22, my acceleration as my time being 2, I can get 2 separate equations, one for AB and a similar one for AC. And like I said, that's giving me some simultaneous equations I can use. If I now start working out some numbers, this gives me 22 is equal to 2U, and a half times this is going to be plus 2A. Looking at the next one, I'm going to get 126 is equal to 6U, and then that's going to be plus 18A. Like I said, we've got simultaneous equations now that we can solve. I'm going to choose to times this one by 3 to make the u's the same, and I can subtract them. So if I times this by 3, I get 66 is equal to 6U plus 6A. Take them away. That gives me 60 is equal to 12A, and therefore the acceleration is going to be 60 divided by 12, which is 5 metres per second squared. That's the first part of the question. Final part of the question is find the speed of A. Well, the speed of A is just what our U value is. So all I need to do is take my value, put it back into an equation. I'll put it back into here. So from that I've got 22 is equal to 2U plus 2 times 5, which is 10. And that leads me to an answer of U being 6 metres per second. You will meet many of these questions when it comes to the A level. Like I said, diagrams and use of those formulae comes up a lot. I hope you enjoy the rest of this document that we've put together for you, and we do look forward to seeing you in September to actually start the A level proper. Thank you.